NASA is known for giving out basic information. They have found that this new planet is not only interesting because of its size and location, but also because it has lights that look like they could be fake. Is it possible that we are finding out secret facts about the world that could change the way we see it? Could this find mean that there is life on other worlds at some point? Come with us as we look at NASA's interesting findings and try to figure out what these strange lights mean. NASA sent the Dawn probe into orbit around the Sun in 2007 to look at the most interesting objects in our solar system. Dawn was very well equipped with 3 ion engines, which let it start an amazing trip. Dawn's journey began with a 14-month study of Vesta, the belt's second biggest asteroid. At this point, Dawn sent back detailed pictures and information about Vesta's strange surface and different land reports. After finishing its main job at Vesta, Dawn set off on the second and possibly most interesting part of its trip, a close look at the small planet Ceres. Because it had ion engines, Dawn could have left Vesta's orbit and gone on a mission to reach Ceres, which would have been hard for a spacecraft with chemical power. When these engines were given a steady, gentle push, they helped Dawn move very far and get into a steady orbit around Ceres. Italy's JPI Piatti was the first person to find Ceres in 1801. It is the biggest rock in the asteroid belt, which is the area between Mars and Jupiter. Before it was given a new name in 2006, it was thought to be the tiniest small planet in our solar system for a long time. With a diameter of about 950 kilometers, Ceres is the biggest and most important asteroid in the belt. It is also one of the most interesting because of the unique things about it. As Dawn moved closer to Ceres, scientists were looking forward to getting their first detailed pictures of this strange world. They saw bright spots all over its surface, but the biggest one stood out in a huge crater that is now called the Inhabited crater. Scientists were briefly interested in these bright spots and came up with some ideas before Dawn's mission. The Hubble Space Telescope took a blurry, low-resolution picture of Ceres that was the best picture we had of it. Scientists didn't know much about this small planet, so the chance to finally get a close look was exciting. What riddles does Ceres want to solve? What new information was waiting for the mission? Dawn promised to help us learn more about how the nearby planetary system formed and how water shapes planetary bodies. Ceres' bright spots were different from those on other planets. They look like they are made of something very shiny, maybe salts that were left behind when water evaporated. This made cryovolcanism on Ceres possible. This is when volcanoes explode with water or salty liquids instead of molten rock. But what are these strange lights, and what do they tell us about Ceres? Could they be proof of ongoing geological action, or something even stranger? Since Ceres is so big, heavy, and has the possibility for water and ice, it is different from the other bodies in the asteroid belt. Ceres is different from most hard asteroids because it looks more like a comet. This makes us think it may hold more information about the early solar system than we thought. The Dawn probe finally started getting close to Ceres in the middle of 2015. It had been on its way for 2 years. This was a very important part of the mission because Dawn gave us our first close-up views of the biggest object in the asteroid belt. As Dawn got closer, the pictures of Ceres got more detailed, giving us short glimpses of a world that had been hidden before. The first pictures showed a surface with holes that show it has been hit many times in the past. Scientists and space fans were interested in more than just the holes, though. There were also some strange bright spots that stood out against the darker, rougher ground. The scientists were buzzing with ideas about what these bright spots were as the shots kept getting clearer. Were those spots of ice reflecting light, or could they be something much stranger? Theories ranged from mineral layers to signs that a cryovolcano might be active. A closer look showed that the brightest spot wasn't just one thing, but might have been a mix of several different areas. This new information only made the puzzle stronger. It became more likely that these were salt layers left over from water sublimating. Based on this, it seems that Ceres had or still has some kind of geological activity that can bring water or briny liquids to the surface, where they quickly evaporate, leaving behind bright, shiny layers. These new facts about Ceres tested what people thought they knew about it and showed that it is a more complicated and changing place than they thought. These kinds of features made it more likely that there was water or briny pockets below the surface. This could have big effects on how we think about the chance of life in our solar system. What, though, makes Ceres so important compared to other planets? Ceres is an interesting world that is often called a cold planet with a rough but fragile surface. Asteroids in the belt are mostly made of rocks and metals, but Ceres is different because of how it is put together. Compared to its neighbors, it has a much less dense structure because its surface is made up of water ice and hydrated rocks like clays and carbonates. Based on this makeup, it looks like Ceres has a lot of water in it. Even though the top is rough, ice and other volatiles are trapped inside. This cold feature makes it look more like a comet than a normal asteroid, suggesting that it may have been made up of a mix of rocky and icy materials in the past. Ceres shows even more interesting parts of its structure as you dig deeper below its surface. The dwarf planet is thought to have a segmented interior with a core and a slushy mantle. This part of Ceres is thought to have a lot of water ice and make up about half of its overall volume. The mantle could be a mix of rock and salty water. It circles a core that could be denser and made of silicates or other dense materials. Ceres may have had liquid water in the past, especially if its core was heated by nuclear decay early in its history, since there is a lot of water ice there. This structure inside Ceres makes it different from the asteroids nearby, and it makes us wonder if it could be active geologically and what role water played in its formation. But that's not all. Finding ammonia clays on Ceres makes us think that the dwarf planet may have formed in a cooler part of the solar system and then moved closer to the sun. The idea of underground brines is supported by the fact that ammonia lowers the freezing point of water. These new details about Ceres' structure and past not only help us learn more about this interesting dwarf planet, but they also tell us a lot about how icy bodies evolve in the rest of the solar system. When we compare cryovolcanism to the more common volcanic action we see on Earth, we can see that it is a unique and colorful geological process. Frozen volcanoes, also called ice volcanoes, don't release liquid rock like regular volcanoes do. Instead, they release volatile gases like water, ammonia, or methane. In the very cold places where cryovolcanoes are found, these substances can be found as either liquids or gases. Cryovolcanoes on Ceres work by letting water with salts that have been dissolved reach the top. This salty water quickly sublimates when it comes into contact with the empty space around it, going from being solid or liquid to gas right away. It leaves behind bright, reflective salt layers. The strange bright spots on Ceres' surface are made up of salt layers. One of these bright spots, called Spot 5, is in a crater called a crater and is the most well-known of these. A lot of attention has been paid to this area because it is very reflective and the Dawn probe has seen strange fogs there. It is thought that these fogs are caused by water sublimating, which means that cryovolcanic activity may still be going on or may have happened not too long ago. Ceres also has a number of other bright spots, each with its own traits. These spots aren't just in one area. They're all over the small planet's surface. This suggests that cryovolcanism may happen all over Ceres. These bright spots make Ceres stand out as a unique object and bring up important questions about the possibility of life in our solar system. Ceres is changing and growing, which goes against the idea that it is a geologically dead world. With each new picture that the Dawn spacecraft took of Ceres, more surface traits became clear. Ceres has a lot of craters on its surface. Each one tells a story about the small planet's past. Some holes aren't very deep and have been worn down over billions of years, which means the surface is very old and has been hit by many objects. Others have been better kept and have sharp edges and deep bowls that point to more recent impacts. It's interesting that Ceres doesn't have as many craters as was first thought. This could mean that the planet is being renewed by geological processes that are wiping out signs of older impacts. One idea is that Ceres' icy surface lets a type of cryovolcanic renewal happen, in which materials below the surface sometimes rise to the surface and cover up older features. The fact that this geological activity is still going on says that Ceres is not a static world, but one that has been and may still be changing. The fact that Ceres' surface has cracks, ridges, and faults is more proof that its surface has changed shape. These traits show that the outside of Ceres has been under a lot of stress and stretching. Some of the cracks look pretty new, maybe only a few 100 million years old, which means that the crust is still moving around a bit. Ceres' ridges and flaws were probably made when the surface was stretched and pulled apart. Mountain ranges and compressional ridges, on the other hand, show where the surface was pushed together. These different qualities make a look into the complicated processes that have changed Ceres over time. A big dome-shaped mountain in one of the craters shows that there may be stress or upwelling inside the rock, which could be related to cryovolcanism. This trait, along with the large number of cracks and ridges, shows that the surface is moving and changing. Dawn's mission has also found interesting surface makeup. NASA's data has shown a lot more than just the bright spots and reflective salts on Ceres' surface. These materials are very important for understanding the planet's geological past. In some places on Ceres, for example, there is a dark, fine-grained substance that is very different from the brighter salt layers. This darker stuff is thought to be a type of carbon-rich substance that might be biological. It adds another level of complexity to Ceres' makeup and suggests that prebiotic chemistry might be possible. The link between these things and the icy surface might have something to do with the chemical reactions going on Ceres. Also, the finding of organic compounds on Ceres has made a lot of people interested in studying life in space. Carbon-rich mixes have been found to contain organic molecules, which are the building blocks of life as we know it. These findings are especially exciting because they show that Ceres might have conditions that allow more complex organic molecules to form. There may be life on this dwarf planet, or at least the building blocks for life, because these chemicals are there. Another strange thing about Ceres is the large number of strange dome-shaped buildings that are there. Some of these domes are up to 6 kilometers high. They are thought to have formed when processes deep in the Earth pushed material through the crust. Based on their sizes and shapes, they may have formed because of action at a cryogenic volcano or because of pressure inside the Earth pushing materials upwards. To figure out Ceres' geological past and internal structure, you need to know about these formations. The gravity data that Dawn collected has also helped us understand how the densities inside Ceres are distributed. Gravity changes show that the dwarf planet Ceres has different layers. This suggests that Ceres' core may have complex structures, such as a subsurface ocean or briny pockets. These findings are very important for learning about Ceres' past temperature changes and its ability to support conditions that are good for life. The Dawn project has changed not only what we know about Ceres, but also how we think about other small planets in the solar system. Scientists are hoping that by looking at more data, they will be able to figure out what this fascinating world is hiding and how it might help us understand how planets evolve and grow.